All right, so when I look at this one, how is this different from the previous? How this is different from the previous is that it's not a 30, 60, 90, and it's not a 45, 45, 90. So I still want you to find the missing sides, but this time you're going to have to use the trig ratios in a different way. So I will ask for A, and C. So I can find angle A, which is uppercase. I can find that by going 90 minus 39. Yes, I will show work. And that's 51 degrees. Okay. Now I'm going to make a decision, whatever one I want to find first. It doesn't matter if I find A first or C first. It doesn't matter if I use the 39 degrees or the 51 degrees. Okay. I'll use the 39 just because I feel like it. So if I'm going to use a 39, and I'm going to find A because I feel like it. So I see A. Okay. Well, A is adjacent. I can't do adjacent over hypotenuse. I don't even have my hypotenuse. So I'm going to have to use this 6. That means this is going to be opposite over adjacent. If I'm doing opposite over adjacent, I know that means tan. So I'm going to go tan of 39 degrees equals 6 over A or 6 over X or whatever. Multiply both sides by X. Divide by tan 39. Now I'm going to pick up my calculator. I'm going to go 6 divided by tan 39, and I get 7.40. It didn't specify how to round. Since it didn't specify how to round, we will automatically round to the nearest hundredth. So instead of 740, it'll be 741, and that's A. Now I have an option. I can now do this squared plus this squared equals this squared in square root. Or I can just use another ratio and figure out C. I'm more about the ratios than doing the Pythagorean theorem. So I'm going to use my 6, and I'm going to use this. So that's opposite over hypotenuse, so that's sine. Sine of 39 is equal to opposite over hypotenuse. So I do the same thing, which ends up being 6 divided by sine 39. 6 divided by sine 39. And I get 9.53. Okay, now I want to show you the Pythagorean theorem in case you want to do it. 6 squared plus, what was my A? 741 squared equals C squared. So 36 plus 7.41 times 7.41, 54.9081. Add it to 36. I get 90.9081, and then I'm going to square root that second squared, the second answer, and I get 953. That's exactly what I got here. So I don't care. Whatever you want to do to get the answer. Okay? All right. I'm going to show this one in the same way, but a little bit different. So I'm going to find y, and then there's x I need to find, and y, lowercase y. So this is 51. Oh, well, we know it's 39 because it's the same problem over there. So that means angle y is 39 degrees. I'm actually going to use angle 39 to help me, and I'm going to do figure out y. So I'm going to use tan because that's opposite over, I'm going to use sine because that's opposite over hypotenuse. So I'm going to go sine of 39 equals x over 9. So I'm going to go 9 sine 39. 9 sine 39. And I get 566. So I just figured out x. Let me repeat again. Decided to use my 39. I'm going to use my 9, which is the hypotenuse of it, and this is opposite it. That's why I picked sine. Now I'm going to do the same thing, but I'm going to do adjacent over hypotenuse. So that would be cosine of 39 equals, I mixed them up. That's y that I figured out. Now I'm figuring out x. So be careful, don't do that on the test. So this is adjacent over hypotenuse. And now I'm going to go 9 cosine 39. So I go 9 cosine 39, and I get 699. That's perfectly rounded. Now I want to tell you, let's say I decided not to do that. Let's say I just decided, here's my triangle, I use my 9, and then I figured out my y, which is 566. I can do the Pythagorean theorem, x squared plus 566 squared equals 9 squared. That's 81. Do the 566 squared, subtract it, square root, and you'll still get the other side, which is 699. Okay? All right. Now, what's the difference between these ones and these ones? These are special triangles. It's a 30, 60, 90. So what's across from the 30? 1. What's across from the 60? Rad 3. What's the hypotenuse? 2. So I've got to figure out rad 3 times what is going to give me 3 rad 3. Some of you just see it. Rad 3 times what gives you 9, and that's 3 rad 3. Let me show you if you don't know it, and that's fine. So I start with rad 3, and I need to get to 9. So if I multiply the radical by itself, you're left with 3, and then times 3 gives you 9. There's a 3 rad 3. Or rad 3 times x equals 9, divide by rad 3. Rad 3 is 9 rad 3 over 3, which is 3 rad 3. I don't care. Get the right answer. So then I multiply this by 3 rad 3, and I multiply this by 3 rad 3. So this side is 3 rad 3, and this side is 6 rad 3. All right, 45, 45, 90. 1, 1, rad 2, same game. You can just see it, which means you know it's 5 rad 2. Oops. I should do that in pen. Or you play the game where you go rad 2 times what gives you 10, multiply it by itself, and then times 5 is 5 rad 2, just what I got. Or rad 2 times x equals 10, divide by rad 2. Rad 2 is 10 rad 2 over 2, which is still 5 rad 2. Okay? Now that I know that, I multiply this by 5 rad 2, and I multiply this by 5 rad 2. So both sides are 5 rad 2, 5 rad 2. I know you know they're both the same. You need to show it. All right, find the exact value of a negative. I don't like negatives, so I'm going to find the coterminal. So I'm going to go 360 minus 135, and I get 225. Now that I'm living in a positive world, I know that's my third quadrant. 225, 180, subtract them, 45. I knew that anyways because it ended in a 5. So negative 1, rad 2. I might want to label it. This is opposite, this is adjacent, this is hypotenuse. Sine of 225, cosine of 225, tan of 225. Sine is opposite over hypotenuse. Negative 1 over rad 2, rad 2, rad 2 is negative rad 2 over 2. Cosine is adjacent over hypotenuse, same thing. Negative rad 2 over 2. Tan is opposite over adjacent, so that's 1. Let's say you don't believe me. Sine of 225, negative 0.0707, negative square root of 2 divided by 2 is negative 0.707. Do them all because you might have forgotten a negative. Negative 225, or cosine of that, negative 7, same thing. Tan of 225 better be 1. Boom. I know that I know. And I'm awesome. Okay, that's your test.